Hi, friends. Today we look at a very interesting topic light and geometric optics. Now, many of you are always curious about trying to understand how things work. What is the physics behind many of these things that work? For example, you may have seen solar cookers, and then a big ray like a disk, and at the center of it, it's like you have a cooker and sun rays fall and then it gets cooked, right? It's not the center, it's the focus of it. And so the question is, how do cookers work? Or you may have seen in a car the side mirror are convex mirrors. But what are convex mirrors? Okay. Or you may have seen lenses, converging lenses, diverging lenses. But more importantly, you must have seen a simply magnifying glass and have wondered how does magnifying glass work? Why you are able to see some image, a small size image, um, or small sized object getting magnified, you know? And these are the questions that arise before us. Or how compound microscope works, or for that matter, you may have been using specs or glasses and to found difficulty in reading something close by, and doctor prescribed some glasses, some power. How does that work? And you may have also seen eclipses, solar eclipse, lunar eclipse. So all these phenomena are related to light, and I'm going to explain you in very simple ways how that works. Let's start with mirrors. If you have seen a mirror, a flat mirror at home, you'd see you stand before the mirror, you see your image. And if this is the mirror, the light from the source gets reflected onto the mirror, and you can see this light coming in and getting reflected. But if the light strikes straight without getting incident at an angle, then for the normal incidence we call it just bounces back. See this? You increase the number of rays, you get a better picture of what's going on here. Light coming in, going out. Incident ray, reflected ray. Now, uh, now let's come to the concave mirror. It's the same mirror we are talking of still, but instead of a flat mirror, now we have a concave. And when parallel rays, say sun rays, come in, they converge at the focus. And if you keep a cooker at the focus, then it hits up because all light gets concentrated onto that focus. So your food get cooked. And now let's take the convex mirror. In a car, at the side mirror, you see a lot of the cars coming from far, but you can see it, right? You just look at the side mirror, you can see the cars coming. So what happens? So all these cars, the incident rays are coming right from the cars, and then they form an image, um, which is smaller, which is smaller than this incident light or incident object. And so this light diverges, and the image that you see is a virtual image. Now, interesting question that we had asked before: how does a uh, a magnifying glass works? And you see here, I'll show you something very interesting. So this is a magnifying glass, right? If the image is is outside the focal length, then what happens? So let's say this is the focal point of the mirror. Focal point of the mirror means what? That if I keep the object right at the focal point, let's say I change the object, I keep it right at the focal point. You see the rays are parallel. The image is formed at infinity, they say, because parallel rays come out. Now, if you move the object away from the focus, you see real image, but inverted images forming. Now, if you move the object between the focus and the optical axis of the lens, you see virtual images, large virtual images, bigger than the object size. And that's the reason why you use a magnifying glass to see objects which look very small, or letters look very small. You can see it bigger with the magnifying glass. So now we know how this magnifying glass works, right? Um, and you can play nicely in this um, link with the object position. Okay, so now next question is that how does telescope work? What is a telescope? Telescope is something that objects which are very far away, and you are able to see those objects from a distance. So a telescope, what does it has? It has two convex lenses. And what is a convex lenses? Before we come to telescope, it's a good idea possibly to understand what convex lenses are. You see here light coming in through the lens, it goes, and then it converges at the focus of the lens. And then the other way is a concave lens, a diverging lens. Light comes in, and then it diverges. The rays come in and diverges, and you get a virtual image behind the lens. The one that I was showing you, if you turn it from convex to concave, you can see what I mean. For example, if you have the object distance, you can see the image very small, right? And that's the diverging lens. Now, when you go back to this, you see the telescope, what's going on. That first of all, you have these parallel rays coming in, and those parallel rays forms a real image at the focal plane. And an eyepiece has a very short focal length that acts as a magnifier. So you have seen the magnifying glass, how it works. So let's say it has a very short focal length, the magnifying glass, and so it forms an image at the focal length of the magnifying glass, and then you can see the image at infinity, the after normal adjustment. So you will be able to see light which with the object far away. You collect the parallel rays, it converges at the focus of the second lens, and then you're able to see the object from very far away. Now, other thing is the microscope, where you are placing the lens very close to the object, and then you use same here two lenses to see. So one is acting as an objective, which is very close to the object, and then other as an eyepiece to see the image. Some of the problems that you come across in daily life are reading things. For some people, they have eye issues, right? With age, these things increase more. So what you do is you need lenses to correct the power so that you're able to read. And way you do it is the two kinds of problem. One is you cannot read things which are far, and other problem is you cannot read things which are near. So things which you are near you cannot read. You use this. The problem that happens is that the images are supposed to form at the retina of the eye, and it gets the cornea acts as a lens, and the image should form at the retina. But what happens is that because the images are formed, they are formed not at the retina, but they are formed beyond the retina, and so they need to be brought to the retina using a corrective lens, which is a converging lens. The similar idea is very similar to the magnifying glass. On the other hand, you have the long distance objects you cannot see, and that's the myopia, it's called. And you need a diverging lens where the image was forming before the retina, and you need it to basically take it little far away and bring it to the retina. So another issue that we can always look at, light in general, a phenomena that is associated with astronomy. And so the solar eclipses and the lunar eclipses, there's a beautiful animation that we have created, how the shadow of the moon falls on the earth in terms of solar eclipse, and you cannot see the sun, and how the shadow of the earth falls on the moon during lunar eclipse, and you cannot see the moon. So my wish is that we can make more such videos to help you out to understand science and develop a curiosity for science. But if you like this video, then do subscribe to this channel, like the video, and provide your comments. It will help us to grow and get inspired. Thanks for watching. Have a nice day. Bye.